Before I get started, how many of you guys write JavaScript on a day-to-day basis? Awesome. Now, how many of you write JavaScript unit tests on a day-to-day basis? So a little bit less. Out of you that write JavaScript unit tests, how many of you have write JavaScript unit tests that are run on a CI server, or know what a CI server is? Okay, great. So we're going to cover all that. Very cool. So SICK, the consortium for blah, 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 says that when you're writing tests, they should be these things. That's great. But really, you're an engineer. You're an engineer. You're someone that writes code. And the difference between an engineer and a programmer is that engineers produce quality work. Anyone can be a programmer. Anyone can hack out something and be a programmer. What an engineer does is think through a problem and go through and make something that's quality. What's quality? So quality is work that you care about. Like when you go into work every day, you're coding, and you should really care about what you're doing. If you're a good engineer, you're really caring about the work you do. And you want to show it off. I don't know about you, but every time I write something that's cool, I want to come and get my other engineer friends and be like, dude, check this thing out. Fold left. What? Yeah, awesome, right? That's I love showing off my work. And you shouldn't be afraid to change your work. So this is the crux of the issue. When I work, and I don't work. When I work without tests, I am always afraid that my little change is going to change something else altogether. And when I'm working in that way that I don't know, I get scared and I change less. I'm more conservative, and that's a bad way of working. When you have tests, you're less afraid. So you write JavaScript, that's great. But writing quality JavaScript is hard. Now, many people have said that at this conference that JavaScript's a great language. I agree, it is a really great language, but there's tons of pitfalls. And as JavaScripters, you know a lot of the pitfalls. You know what to do. You're smart. You name space your functions. You're like, oh, I never pollute the global namespace. I'm a boss. I have an awesome namespace. Put everything in my awesome namespace. So you're a hero. Great. Good job. You declare your variables up top because you're like, oh, I know that variables only have function scope. I don't have any block scope. You get that, right? So these are things you have to know. You encapsulate your codes in an iffy. What the cuss is an iffy? It's a immediately executable function expression and immediately invoked function expression. And this is a way to encapsulate your code and make sure that you're, again, not polluting the global namespace. But you got that. You read some blogs. You're a pro. And you know what not to do. You know not to use with because with makes all your code confusing. And you're like, oh, what is that? I don't even know. Honestly, who knows about with? It's crazy. And you remember to always type var in front of things. Like you see this I is global. Like, oh, you're like, what is this, JavaScript 101? That's easy. Everyone knows that, right? Well, not necessarily. You don't abuse eval. So if you know eval, you're like, oh, eval is sweet, and you can hack away lots of stuff. But you're a really good JavaScripter, so you don't abuse it, right? So you're great. But you know all that because you're here and you're a JavaScript guy or girl or man or woman or dog. And you're a rock star. But really, none of us are perfect. And there was a time when I didn't know any of that crap, and I was writing JavaScript, so right? We're all at different stages of learning. We're all at different stages of knowing something, right? And you're going to be working with people that aren't rock stars, and you might not be a rock star, and I'm definitely not a rock star in any way, shape, or form. I just happen to know some things. So we all write bad code. Every single day you're writing bad code. You from yesterday wrote some really bad code that you from today think suck. And if that isn't how it's working for you in your day-to-day life, then maybe something's wrong, right? We're always improving. And it's really easy to write bad JavaScript, right? So it's because of these pitfalls. So we write tests. You write tests in order to write good JavaScript. And you write your tests in JavaScript because you're a JavaScripter. You're not going to be writing tests in Java to test your JavaScript code. Theoretically, you could. Why, right? And you run them in our CI server. Now, I should explain for a moment what a CI server is. It's a fancy acronym. CI means continuous integration. And a CI server is something that says, okay, every time every time someone makes a change to my code base and checks it into their code repository, whether you're using Git or Subversion or whatnot, the CI server is going to be like, aha, he made a change or she made a change. I'm going to check that out, run my suite of tests, and make sure it's okay. If the suite of tests run and something breaks, then it's what's called breaking the build. And breaking the build sounds like a bad thing, but it's actually a really good thing. So what we can do by having JavaScript unit tests that are integrated into your continuous integration server is that front-end engineers can now break the build. Now, why is this a good thing? This is good because before, when you don't have any tests, and you put your stuff out there, you put your JavaScript out there that probably has a with in it for some stupid reason, and it goes to production. A production incident costs more money and takes more time than an incident that's caught when you break the build. When you break the build, you catch it in dev. You catch it before it goes to QA. You catch it before it goes to staging. You catch it before it goes to production. By writing tests and having them break at the very beginning, you catch so much more bugs. And it can save you a lot of money. And honestly, it saves you a lot of time, too. You're not going to be working on those weekends when your site just went down because of some stupid JavaScript bug. So I'm going to describe how we do it. We use Jasmine. Jasmine is just a unit test framework. If you're familiar with Ruby, Jasmine's a lot like RSpec, the same type of format. And I'll show you some examples of that. We use Maven because I work in a Java shop. Now, you could use Ant or Rake. There are a number of tools you can do for build configuration. And I use Jenkins as my CI server, and I'm going to show you how that works. The reason I'm going to demo Jenkins is because it's extremely easy. You can follow along with me and get this up and running if you really wanted to. Jenkins is pretty straightforward. There are lots of other CI servers out there. Anthill Pro is one that's relatively good but costs money. And again, if you're into unit testing and you don't like Jasmine and you really want something that looks like JUnit, QUnit works great. There's stuff out there like Casper, JS, lots of different test frameworks out there. I'm just showing you one way, okay? Not the way, it's just one way. So now it's time for demos. Can everyone see this okay? Yeah, I can see it okay. Okay, great. So let's go in and we'll open this up. Now, in an hour-long talk, I would actually type these things out, but which is always dangerous. But here, I'm just going to show you. So here's some really stupidly simple JavaScript. It's just a greeter function that says, hello, name, right? So let's say I want to do a test for this. So I have a spec, and spec files end with .spec.js, and they're in the specs directory. And if you take a look here, it's pretty straightforward. I describe greeter, and it greets me. So it's the test, and then in there we say we expect NSGreeter Trevor, this function call NSGreeter Trevor, that's me, hi, to equal hello Trevor. So that reads pretty simply. It's pretty straightforward, not really hard to understand, and really it's not really that hard to write. So that's a simple test, and you're thinking, oh, I could write that. If I have a little function that does that, I could write something like that. But your functions are usually more complicated, I hope, than this. So let me show you a couple more examples before I show you how to do this in a continuous integration environment. So so far, how many of you are familiar with Jasmine? Feel comfortable with Jasmine? So not a lot. That's good. So I'm going to do my best to go through this in a sane way. Of course, if you have questions, you can ask me afterwards. Here's an example that uses a callback. So we're all familiar with callbacks, I hope. And here's a callback that runs if you pass the name Trevor. So there's a simple if the name equals Trevor, you call the callback with the name. Else, you're going to throw, you aren't Trevor, all right? So that's pretty straightforward. Again, a trivial example, but I want to be able to show different aspects of how Jasmine works. So again, a describe now. A describe is just a suite of tests. All your tests start with it. The reason we have these words is so it sounds more English-like, which might seem silly to you, but I believe really matters when other people are reading your code. You have a chance to actually describe what you're talking about. So it calls callback if Trevor. One of the things here we're going to do is we're going to create a spy. Now a spy or mock or sub, this is a full concept of mocking. There's going to be a great talk after this one in the Regency Ballroom all about mocking. You should go to it. Mocks are very interesting and complicated beasts. But I'm going to introduce a little bit of it here. Please go to that talk. I think you'll enjoy it. So we're going to create a fake function. What this create spy is doing is creating a fake function that has some things that we can inspect on it. So I've created this fake function called callback, and I pass it into run if Trevor. Right? That's going to go up here and see, Trevor, and then it's going to call callback. But what the spy does is say, okay, I've been called, so I'm going to mark that I've been called somewhere. And then we can run our test, and our test is expect this callback, which is a fake function, remember, to have been called with Trevor. Again, it reads like English, and this just works. So this is a working test for that code up there. Now you might be asking, how do you test that throw and the else? One of the important things you want to think about when you're testing is you don't want to just test a function once. Like you have two branches in this function. One in the beginning of the if, and another in the else, right? So you want to test both branches. You want to make sure that both branches work to have full test coverage. So you can be really confident about your code. So we've tested this if part. Let's try to test the else part. All right. It throws an error and does not call callback if not Trevor. Again, we're going to create this callback, which is just a spy like I explained before. And then we're going to run if Trevor with Orson. That's my son's name. And we expect that to throw you aren't Trevor. Now, there's one thing a little bit different about this. When you're testing throws, you have to wrap your function call in an anonymous function, or it won't work. That's a little thing you just have to know. You put that in the back of your brain, so when you're testing throws, you can take care of that. And then, if you look at this is interesting. We expect callback to not have been called, not to have been called. With expect, you can do .not in front of it, and it will always be the opposite of what you thought. So again, it reads sort of like English. It's pretty straightforward. Okay, so we've shown a really basic one. We've shown one with callbacks. Let's talk about Ajax. So we're all familiar with Ajax, pretty much, and in any complicated or even not so complicated web app, you're going to have a little bit of Ajax sprinkled in every now and again. And one of the problems about testing Ajax is digging into that success function. Now let me show you what I mean before I show you the test here. So check this out. This is a pretty standard looking Ajax call. If you're looking greet user. And what this is doing is I'm going to pass in an ID of a user and make this Ajax call to name.html, which will do some magic lookup to give me back a data structure with a name if I give it an ID. All right? So that's pretty straightforward. And then in the success, there's this anonymous function. And this anonymous function is going to call NSGreeter. So the big question is, how do you get to this anonymous function to test? When I started evangelizing testing, I got a lot of questions about this. They're like, that's impossible to get to. Just give up, right? But that's not necessarily true. What I'm going to show you is that you can test that what happens inside that function will happen. So what we're going to do is we're going to spy on this NS greeter, which is being called, and make sure it's called with the correct data. I'll show you how to do that. Okay, great. So here's our greet user up here, and here's our tests. It calls greeter on success. So the first thing we're going to do is we're going to call our function greet user with 1, which and all that does is returns the result of the AJAX call. And what's happening behind the scenes here is that the mocking framework, or the Jasmine behind the scenes, is not actually making this jQuery AJAX call. It's catching the call before it gets sent out and putting it somewhere to log. And so you can mock out the results of it later. So we're going to mock out the results of that later. We're never actually making the AJAX call. One of the very important parts to remember when you're doing unit testing is that you only want to test the code that is inside the code that you wrote. So I'm not testing that jQuery's AJAX works. I trust that that works. What I want to test is that my code, which I wrote in here, works. Okay? So the one thing I have to do is I have to spy on NSGreeter. So this is just like that create spy before, but we use spy on to say, I know something already exists. This ns.greeter function already exists, but instead of you calling that function, I want to spy on it and log some data. So that NSGreeter function is never going to be called because I put this spy on line 6 there. And then here's the magic. Jasmine gives you this great thing called most recent AJAX request. And you can call that. It pulls out the most recent AJAX request. And we know since we've called greet user, that's going to be this AJAX request. We can change the response to a 200 with the response text of this JSON object. All right, so now that AJAX request has a response, and this is it. And then once we have that response, the success function will be called, right? So once this code is executed, the success function is kicked off, and greeter is called. So then we finally expect NSGreeter to have been called with Trevor. And as you see up on line 16 there, data.name is going to be the Trevor on line 9 down there. So that's how these work. Pretty straightforward. So those are the tests. And I can go into more detail about how the tests work, but what I'd really like to show you is how this works in a continuous integration environment. So the first example I'll show you is doing this in Maven. So how many of you are familiar with how Maven works or what Maven is? So only a couple of you, that's good. Maven is basically a way to bundle and configure Java applications for the most part. And so the way you configure Maven is there's this XML file called pom.xml. It's really ugly. And you put a bunch of stuff in there. And it says, when I type this command, do some stuff. Okay? That's basically the extent of what you need to know about Maven if you don't know Maven, right? And the command to do stuff is mvn. So if we do mvn test, this is going to run our tests. What it's going to do is it's going to run our Java tests, because this is a Java thing. And then it's going to run our Jasmine test. You see down here it says Jasmine test. So that's kicking off and actually running all our Jasmine tests and making sure they pass. So this is Maven running my JavaScript tests. So you're thinking, okay, that's great, but that doesn't mean continuous integration, right? What you really want is a server that runs this Maven tests every time you check code in. So let's get a server. Let's get that started. So go over to this guy. I've already downloaded Jenkins. You go to jenkins-ci.org and download Jenkins, which is a continuous integration server. And when you download it, you're just going to get this jenkins.war. This is the brain-dead simplest way of doing this. You can argue that, okay, fine, I'm not really going to download a WAR and just run it with Java. I'm going to set it up in Tomcat or do something else, but I just want to show you the basics. So to get this guy started, I'll just do java-jar jenkins.war. Oops. And that's going to spin up my Jenkins server. Now what this is doing is just creating a local web server that's going to run on port 8080 on my machine. So it says Jenkins is fully up and running. We'll go back and take a look at what this looks like. Local host 8080. So here's Jenkins. Jenkins is pretty straightforward. You create jobs, you run jobs. That's about it, right? So I'm going to create a new job. Boop, boop. Make it, have a name for it. Jasmine Maven test. Okay. Call the Maven 2 or 3 project. Bloop. Now, the first time I used Jenkins, I was like, what is all of this crap? I don't understand. It was really confusing. I was like, I don't get it. There's too many things, and I gave up. And what I'm going to tell you is don't give up. It's really easy. Just do this one thing to start. See where this says root pom? Okay. We're going to make this the pom on in our Maven directory here. So whoop. If I do an ls here, you can see there's this pom.xml. Great. pwd. So I'm just going to take this directory, copy it, go over here. Bloop. There you go. That's where the pom is. And then I'm going to say run tests. Click save. That's it. Now I have this project built in, this project in Jenkins. I click build now. So you click that. You see it started here. You can look at the console output. Boop, boop. And you can see that this is going to be running the exact same thing that we ran on our on the command line. So that's pretty straightforward. And it passed. Now, if this fails, I'll get a red light, and you can easily configure an email mailing list to send things out to. One of the things that we did at our work is we got a little Arduino board, hooked it up to a siren, and put that on the build machine. So whenever a build failed, the siren would go off and go, wah, 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 wah. And that was really embarrassing. We did that for about a week until our manager told us not to do that anymore. There are lots of things you can do to tell people that you've broken the build. So why is this a good thing? This is a good thing because now you, a JavaScript developer, can break your builds. And that's wonderful because, like I said before, you can catch your bugs before they go to production, which if you weren't doing testing before, you could never do. So you're like, that's great, that's Java stuff, whoopee. I'll show you another example. I'm going to show you an example using Rails. So you can do this exact same thing with Rails. Pretty straightforward in Rails. Let's go to that example. Uh-huh. Oh yeah, of course. You'll regret it. The POM file is pretty ugly here. The good thing is that all you have to do is cut and paste this, and you'll see it work. So let's take a look at the POM. All right. POM files are usually messy. This one is especially messy. So all we're doing is we're using the exec Maven plugin to execute some Java, and here's the boilerplate code that you have to drop in to tell inf Jasmine to run correctly. Just a bunch of mess. You can actually see this. All of this code is on GitHub at trevmex/inf Jasmine, and I'll give you a link to it at the end of the presentation. We only have a few minutes left. I'd like to show you this running in Rails very quickly, as quickly as possible. If we don't have time, so be it. So here's Rails, good old Rails. So this is a plain Jane Rails application. Here in tests, we have JavaScript, and you can see our inf Jasmine directory in here. The only thing I had to change to get this running in Rails And if you're a Rails geek, this is interesting, is I'd add libtask inf.jasmine.rake. So I'd add this rake task. And again, this is online, so you can see what that is. But all we have to do here is bundle exec rake test. And again, what this is doing, if you're unfamiliar with Rails, is rake is like make for Ruby. Bundle exec says use the rake command that is part of this project. So you can see this just works. Pretty straightforward. And so let's do this in good old Jenkins. So the point I'm trying to make with all of this is that setting up continuous integration servers is really not rocket science. It's something that anyone can do. You can do this tomorrow and impress your boss. It's not so hard to set up. So let's call this Rails test. All right, so with Rails, you want to build a freestyle software project. And again, this looks really confusing, but all you have to do to get this going is add a build step, execute shell, and we'll cd into our Rails directory and bundle exec rake test. That's it. That's all you have to do to get this running. You build. And again, we'll look at the console output. It'll look exactly like what we did on the command line. The nice thing about Jenkins is if you can write a script or if you can run it on the command line, you can run it in Jenkins. And if you can run it in Jenkins, you can have alerts, you can have notifications. All of it is relatively straightforward. Anyway, so that's basically it. If you're not writing unit tests, please try it out. Now, unit testing is only one piece of the pie. Functional testing, integration testing, there's a lot to do there. But if you haven't done any testing at all, period, try out a unit test. Give it a shot. Pick a framework. Pick QUnit or Jasmine or Casper, something, and try it out. I think you might like it. I definitely like it. I think it makes me a better programmer. I think it makes the team better. It's just, in general, a good thing to have. If you don't have CI, check out Jenkins. Like I said, it's a simple download and install. You can get this up and running in less than 30 minutes. So please test. Make everyone on your team happier. That's my talk. Thanks so much.